Hello friends, let's solve a simple problem. Add two numbers on a linked list. So our input should be two numbers which are reversed, and all the digits are stored in a linked list. And similarly, we have another number that is also reversed, and it's also stored in a linked list. We have to calculate the sum of the two numbers and set the result in a linked list. So here our given number is 342, which is reversed 243 and saved in linked list. And in same way, we have the next number as 465, which is again reversed and saved as 564. We have to find the sum of these two numbers, and which would be like 5 plus 2 7, 4 plus 6 will be 10, 0, 1 carry forwarded, and 3 plus 4 7 plus the 1 carry forwarded 8. So our numbers is 807, and 807 represented in reverse order is 708 on the linked list. And we have couple of other examples as well, like 00 and all 9. Notice in this case we have more nines on L1 and fewer nines on L2. So we have to write our code in such a way that it would handle all sort of numbers. Like here it's a 5 or 6 digit number, 3 for 7 digit number, and here it's a 4 digit number. So let's start. First, we'll take a variable result, which will also will keep another variable result head as a empty node or a dummy node. Here, each R node is a list node which have two members, self dot val and self dot next. So val and next. So the val will contain the value, and the next will point to the next object, which will have the which will again be a list node, will contain the next value, and we'll take a variable carry forward. We'll keep it as 0 since at the beginning we don't have any carry forward. We'll start our loop. Since we have uh, in L1 and L2 we have different number of different number of elements in this linked list. We will loop until we have elements available in either of the uh, linked list. So L1 is not known, or L2 is not known. And once we have once we are in the loop, let's check whether L1, let's take a variable sum equals to 0, and let's check whether L1 has value or not. If L1 is not known, then sum plus equals to L1 dot val, and we'll move L1 to L1 dot next. So L1 will now point to the next node of L1. Similarly, we'll do the same thing for L2. If L2 is not known, sum plus equals to L2 dot val, L2 equals to L2 dot next. Now, now we have the sum of L1 val and L2 val in the sum variable. Let's save it in a node and also check whether we have any carry forward or not. So we'll add our existing carry forward. So sum plus equals to carry forward. Once we add the previous carry forward, let's check whether the resulting sum gives us any new carry forward. We'll have carry forward 1 if sum greater than 9, else 0. And now we have our sum. We'll save the value result. Since we are in a loop, let's save the result in a next list node sum modulo 10 and dot next result equals to, and move our result variable to result dot next. So, and at the end of the loop, we'll check whether so once we are out of the loop, that means we have completely traversed L1 and completely traversed L2. And at the end, if we have any carry forward, in that case, we'll add a new node. So if carry forward greater than 0, which would be 1, then result dot next would be this node carry forward result equals to result dot next. And note our result is always pointing to the next one. In that here we do not need any next node, since we are we have already traversed the whole L1 and L2 and already considered the carry for last carry forward. We'll return the result, but we'll return the result head. And since in result head we started with a dummy node, our actual result will start from the result dot next. So we'll return result head dot next. Let's test. Yeah, we have it. We are getting the proper output. Let's check for other examples. Expected 0, output 0. Case 3, 8001. Thank you for watching.